We move on to Rosalyn Putland, and she's from the Centre for Environmental Fisheries and Aquaculture Science, Cefas, in England. Welcome, Rosalyn, and the floor is yours.
Hi, thank you. I assume you can hear me? Okay.
Yes.
Yeah, great. Okay, so yes, as Hans mentioned, I'm going to be talking about the Work Package 6 combination today, and this work is on behalf of myself and Adrian Farkas and Nathan Merchant at Cefas. So to give you a brief overview of the concept of this work package, which is depicted on the right, as highlighted throughout today, maps of shipping noise are needed to guide policy and decision-making on the management of underwater noise. Measurements and models both have different advantages. So the measurements provide accurate in situ observations, but are spatially limited, whilst models produce an extrapolation with possibilities for past, present, and future predictions. However, validation of modeled maps using field measurements has been limited, especially using multiple sites with a large geographic coverage and multiple recorder types. So that's where JOMOPANS steps in and provides some of that for us. The aim of this work package was to provide a separate validation comparing the distribution of measured and modeled noise. We then could identify sources of error or uncertainty from this comparison to help optimize future models before producing confidence maps of final outputs, which are needed to give decision makers confidence that marine policy can be guided by reliable predictions and also quantify the level of uncertainty. We would like to acknowledge Work Package 4 and 5 at this stage, as their close collaboration definitely allowed this combination of the measurements and model data for work. So in terms of our approach to the combination, in 2018, iteration 1 predictions were compared to field measurements at 8 JOMOPANS stations, which allowed for the identification of frequencies where the discrepancy was greatest. Validation was then repeated using second iteration predictions on an independent data set to assess the decibel error across the percentile range, to assess goodness of fit, and identify consistent errors before a final model configuration was chosen. The combination has more recently been conducted on 2019 model predictions for nearest grid positions and measurement data for 15 JOMOPANS stations, which are shown here, to provide a larger temporal and spatial coverage. And that's what we're going to be discussing today, the 2019 data. So firstly, just to show you some overview of the measurement data, and hopefully this goes on from some of the work that Jens was talking about this morning. So this figure shows sound pressure level by different size circles at the 15 JOMOPANS. Each subplot shows yearly, median, decade, or broadband sound pressure level, as indicated in the lower right. So just to kind of give you the take-home messages, the southern North Sea generally had higher noise levels recorded compared to those in the Kattegat and the northern North Sea. For example, Belgium West Hinder, number 8 in the lower left, had some of the highest broadband sound pressure levels, and that may be due to some of what was discussed earlier this morning, the pile driving noise or potentially wind farm noise from further away. While Denmark Anholt, number 2 in the Kattegat, actually had the lowest sound pressure levels over the broadband frequencies. So this graph just shows what I've just been talking about a little bit differently. So it shows the third octave frequency levels, decibel levels on the x-axis versus station on the y-axis, as well as decade and broadband levels on the far right, so those that I showed you in the previous slide. It kind of echoes that the low frequency sound often dominated noise levels across the site, whereas in the high frequencies, there tends to be a lot of similarity across stations with very little variation. But it is important to note that for some stations, only a couple of months of data was available for 2019. So monthly information was also considered, but for time today, I'm just going to be focusing on the yearly comparisons. So it was also important before we started delving into comparing model to measurement data to begin to look at some of the station characteristics and some expected possible sources of uncertainty that we were going to see. And so this is really based upon the fact that Work Package 4 model was based around predictions for ship traffic and wind noise, whereas we did expect some additional sound sources to be present. Just to highlight some of the expected sources of uncertainty going clockwise around this slide. So on the top right, shows a sediment map, and there was a high degree of sediment uncertainty in the Kattegat. In the top left shows a couple of the German stations and their proximity to offshore wind farms. In the bottom right, we have some information from the ScotMap data that was collected, so showing 2 of the Scottish sites we had, and it was has netfrops trawls on there. And something that was mentioned this morning as well was actually that some vessels may not have been included in AIS records, such as fishing trawlers. And then finally on the bottom left, some thermocline information that we received from the Swedish Institute. So this is just salinity and temperature data, but if we combine these to look at sounds breed profiles, they may have come into play. And we just want to thank the other JOMOPANS partners for their assistance in highlighting some of these additional sources or possible reasons for uncertainty. Now onto the comparison. So I'm sorry they're quite blurred on your presentation. But these plots are similar to earlier, with frequency on the x-axis, station on the y-axis, and the colour representing sound pressure level for measurement and model. And when you compare the difference, on the bottom graph, you see the red-blue colour scale. So blue represents that the model is lower than the measurements, and red that the model produced higher predictions than measurement. Really, the take-home messages I want from this is that the low frequencies showed mainly blue, so that the model was lower than measurements, and this could have been affected by sediment uncertainty. In the mid-frequencies, there was both red and blue shown on this figure, and that was because there may be some additional noise sources present. And in the high frequencies, they were generally consistent between the two, with very little variability. So in terms of providing our last point for our kind of objectives, we wanted to provide a confidence map explaining the discrepancies in measurements or differences. And this, I must stress, is a very simplified explanation of the differences in yearly broadband sound levels, with the decibel values indicated in the table. The table above shows the decade levels, as well as broadband levels, with blue that the model is lower than measurements, red the model is higher than measurements, and I've actually coloured in the ones that are greater than 6 decibels. And this is mirrored by the large circles in the map. So to go through some of these in detail, Station 3 to the west of Denmark was within close proximity to an oil rig. Station 5 and 18 in the centre of the North Sea had generator and seismic survey noise present. Station 6 was close to Germany, was within close proximity to an offshore wind farm. Station 10 of Scotland had fishing pressure, which may have not been on those VMS and AIS records. And Station 17 in the Kattegat had high sediment uncertainty. And of course, again, I just want to stress these are simplifications, and a combination of factors may have led to uncertainty. So lastly, just to give you an overview with some summary and some general recommendations from our work. So our overall aim was to compare the measured versus modeled data to determine how much confidence could be placed in the final outputs. Overall, the general pattern of uncertainty was that the model predicted sound levels which were lower than measurements at low frequencies, while more closely agreed with measurements at high frequencies. And the validation highlighted the difficulty in predicting shipping noise due to multiple uncertainties. At this point, I just want to say there is, of course, a trade-off, because if additional inputs were added to the model to improve accuracy, this would also increase model complexity, such as computational cost, time, and difficulty in interpretation. And this is something potentially Work Package 4 may also be able to comment on later. In terms of recommendations moving forward, a more detailed analysis of individual ship passages, looking at thousands of closest point of approaches in the measurement and model data, could potentially improve validation of the ship noise model. But I must stress this is a very big task, which would need to be automated. Further data treatment could also separate intermittent and continuous sources, as it was evident that some of the monthly medians may have been skewed by intermittent sound sources such as seismic surveys. It may also be useful to consider sub-regions of the North Sea, such as the Kattegat, Southern North Sea and Northern North Sea separately, to potentially distinguish environmental variability or different sound propagation properties. So this in the past has sometimes been referred to as acoustic basins at different noise conferences. And kind of the last thing I just noted on this slide is moving forward with future management. And we want to emphasize to continue measurements. So it's really something that came out in the validation was that the measurements proved essential in ground truthing predictions and monitoring trends in shipping and general ambient sound. And with that, I'd just like to finish. If anyone has any questions, I'd be happy to answer them afterwards. Thank you.
Okay, thank you very much, Rosalyn. And we are looking for some questions. And in the meantime, there's a call for Ewan Edwards to come to the presenter place and not in the Zoom. And maybe we shift actually the program that Jacob will start first and then we have Ewan. But in the meantime, are there any questions in the chat?
Yes, thanks. I have two questions for Rosalyn. How detailed was the seabed information in the propagation model? And the second question is, how much did flow noise contribute to low frequency measurements?
Yeah, thank you for those questions, whoever asked them. Yes, so the first one about how detailed was the sediment information for the propagation. So I was provided for some of the validation with some sediment grain size information from WAP package 4. I'm sure that Chris can probably also, or others from WAP package 4 can elaborate on their detail they included in their actual model. But for us, we were just looking at sediment grain size. And then the second question about flow noise, it was definitely something that was present, particularly at some of the shallower stations in the southern North Sea, so particularly the ones in the Netherlands and the Belgian sites. This is something that individual partners sometimes helped to sort of filter out or highlight in particular months of the year. But it was something that at certain frequencies we could pull out and is mentioned in greater detail in kind of the overall report that we'll have on the website.
Great, thanks, Ross. Chris also commented in the chat.
Chris is working with you in the chat. Yeah, I also had a question related to that with the expectations about the low frequency propagation in the shallow waters, because that could be another reason for the mismatch between the modeling and the real time of the real data.
Yeah, and it was something this morning that was highlighted with having the deep water station as a comparison. So it's something I didn't talk about in the talk, but having shallow water places and deep water places allowed us to really pull out whether there would be a difference because of that low frequency propagation, because the model was depth averaged. So yeah, having that into consideration.
Cool. Thank you very much. In view of the time, I think we will move forward and we'll see you back later at the end of this session for maybe some additional questions. Thank you, Rosalyn.